We're doing area. We're starting our section on area. So let's go with the essential question. How are the formulas for areas related? How are the formulas for areas related? All right, we're going to start taking down the area formulas. But first off, let's get this definition down. Area is actually the amount of surface covered by a figure. Surface area. Amount of surface covered by a figure, and it's always measured in square units. Area of a square. So area of a square, if you know the side of the square is a number, and I'm going to label it with an S, make sure it looks like an S and not a 5. I'm going to if you took base times height on a square, well, base times height would be taking the same number times itself. So that's why we say S squared. The rectangle. Rectangle, this is something we've been exposed to. Be sure to put in your rectangle where the B and the H are typically located. But it's base times height, or length times width. But this is not something new. We've been exposed to this before. These are the two formulas we'll be dealing with. And I need you to somehow, circle or box that our answers are always going to be in square units, either square inches, square feet, square meters, and so on. Square centimeters. With this, I notice that it's a rectangle, so I'm going to use the base times height method. I look at the rectangle area formula. We're going to use base times height. So if you have 9 inches times 6 inches, that's a total of 54 inches squared. Wait, where did I get this inches? You go back to the picture. Go back to the picture, and it's square inches. So we notice, wait a second, the picture has tick marks all the way around. We're looking at a square here. So area of a square, going back to the top, is a side squared. The side we're dealing with is an 11. Well, if I square it, this 2 means that you take 11 times itself. So it's not 22 as an answer, it's 121, and then be sure you square the units. It's meters squared. Now we're going to take this further. What if you are dealing with a floor plan? What if you're dealing with a floor plan and you've got to figure out the area of a floor plan? When you have separate rectangles, or when you have a weird figure, break it up into rectangles. And we're going to label them like with a capital A and a subscript of 1, capital A, subscript of 2, capital A, subscript of 3. And I'm going to find their individual areas using base times height. In the end, we will add them. That's in the end. So I'm going to erase this. I just want you to see where we're heading. We're going to find individual areas, and then we'll add them in the end. So the first area, base times height, so the base of 4 times a 3. Looking at 12. And then we look at the second area, looking for a base and a height. Wait a second, base is not found down here. So you go to its opposite side that it's congruent to, which is a 3. So base and height of the second area is a 3 and a 9. So that's area is 27 centimeters squared. And then the last area, it's more clear of what its area is. So we're looking at a base of 5, height of 2. When we get those 3 individual ones, now we're going to add them together. So the total, taking all 3 pieces, 12 plus 27 plus 10 we've got a total of 49 square centimeters, or centimeters squared. Just like before, we're going to separate in areas. I'm going to call the top one the first area and the bottom one the second area. In the first area, looking for base and height. The bad thing is about the first area is the base is a combination of more than one 3. I'm going to use a color or a squiggle to show that, wait a second, that base is going to be a total of 6. So 6 times 2. First area is 12. Going to go to the second area. The second area also does not have a number on its bottom because that 12 is saying it's going from one end to the other of this abstract piece. So I'm going to have to go to the top. The top is a combination of a 6 and a 3. So I'm going to use a different color to show, all right, the second area uses a 6 and a 3. That's a total of 9. So we've got 9 times 3, giving us a 27. All right. So we're going to start labeling. First rectangle, second rectangle. We're doing base times height. So in the first one, the base is not all labeled. So then because rectangles have opposite sides being congruent, I look at the top. Hey, it's a 7. So taking 7 times the height, 3, we've got a total of 21. So there's 21 square inches in the top. And in the second area, looking at base times height, it's ironically a square since both sides are the same. So I could have either taken 3 and squared it, or taking 3 times 3. Once I have both areas, I'm now ready for the total. Adding the two together and writing in my final answer. Making sure I keep units being squared. And then I'm going to go through, label, first area, second area, third. Dealing with base times height on each. So within the first area, I don't have a base on the bottom, but then I look at its opposite side, 3. So 3 times 7, we get a total of 21 for our first area. Then we go to our second area. Again, I don't have a number on the bottom, but I look at its opposite. So we're looking at 4 for the base. Get an area of 40 for the second. The last area, looking at the bottom base, 14 times its height, 5. Total of 70. So I say the word total a lot. You've got to find the total amount individually, and then you have to find the absolute total. So add all 3. 21, 40, 70. So 131 meters squared.